Hello and welcome back to the lecture on applied econometrics. So we have been talking about different tools and techniques to ensure that our econometric model is as correct as possible. We previously have seen the functional specification. We want to specify the exact or the right function for our model. We have seen the problem of multicollinearity. We have seen the problem of heteroscedasticity or autocorrelation. So all of these different techniques that we have learned is basically to ensure that my econometric model is as correct as possible. Now, one essential problem that we cannot get away with is the problem of model specification. So what it means is that we need to ensure the variables that we are including in the model are exactly the right variables. So that means that we do not include something that is irrelevant, or we do not exclude something that is relevant. So that is one aspect of the model specification problem. And the second aspect of model specification problem is that we are able to measure the variable correctly. So what I mean by that is that the variable, let's say if I am talking about a particular variable, let's say the impact of education on wage. So now in education there are so many other factors perhaps which are needed to be measured along with education, for example your ability, your talent, but you cannot have a proper variable to actually identify your, say, let's say creativity or talent. So all you can do is you use the variable called education, and that you kind of consider as a proxy for the variable talent. So you cannot measure the variable talent, right? So this is another problem where we actually face the problem of model specification. So let me write it down. So the first problem is inclusion of irrelevant variable or exclusion of a relevant variable, or exclusion of a relevant variable, whereas second problem lies in our ability or inability, I'd rather say, to measure. It's a measurement problem, inability to measure the exact variable of interest. So if we cannot measure, let's say, talent, so then my model, so the impact of talent would be captured somewhere else, and then my model will not be correctly specified. So these are the two problems that we are going to talk about when we are going to discuss model specification. So essentially what we do is we can actually use all these different tools and techniques like functional specification. We can check for multicollinearity, we can check for heteroscedasticity, we can check for autocorrelation, but then that does not ensure my model is correctly specified. So we have to sort of take care of these two things. Okay, all right. Now, why exactly this model specification is a problem, or why exactly inclusion of an irrelevant variable or exclusion of a relevant variable is a problem? Now, the problem is that why can't we identify that? So that is even, like we should ask this question, why can't we identify, or why the identification of irrelevant variable in the model or exclusion of a relevant variable in the model is a difficulty? Now, the problem is this: they're correlational model. Okay, so this is something we have to understand. They're correlational model. So the relation between y and x, we sort of look at the correlation. Now, let's say a variable which is let's say irrelevant, but you might actually see some correlation of the variable which is not relevant with the y variable. So you might feel that, well, if I see some correlation, so perhaps there is some, the x variable is actually influencing my y variable, but actually in reality it is not. Because it is a correlational model, so there might be some aspects which are picked up by the specific variable which I am calling an irrelevant variable, right? Now, so this is the reason we can never be sure of if my variable of interest is included or if my variable of irrelevant variables are excluded. And this is specifically the reason why I can never be sure if my model is correctly specified. Okay, in econometrics, so that is something we have to remember. Doesn't matter how much we try, we can never be sure that exactly those variables which are actually influencing a y variable are included in a model, or if something irrelevant by mistake we have actually excluded in our model. So in this lecture we are actually going to see the sort of ways to identify if a variable is, a irrelevant variable is included or a relevant variable is excluded, and what is the impact of such exclusion or inclusion. Okay, so So how do we actually now the fact that it is a correlation model, and now the fact that it is a problem, how do I really identify if my model is correct? So now I said that I can never be sure if my model is correct or not. Now given that, as an econometrician, as an economist, I would want my model to be correctly specified, as correctly specified as possible. Now there are three different ways to actually identify a correct model, or there are three different sort of angles you can take to sort of address it. One is the economic theories. Okay, economic theories. So this is the first thing. So you have your economic theory. So your theory actually talks about certain facts. So your theory is at least partly talking about the truth, if not the full truth. So your economic theory always helps you as a guiding principle to approach an economic problem, and then you also know from the theory what would be the variables of interest. Okay, so that is first thing. The second is the assumptions that you make. So the assumptions you make both in economic theory as well as your models. So what do I mean by that? So let's say in economic theory, you are talking about the impact of, let's say, education on wage. So you keep certain variables constant. You say given these variables are constant, let's say. So you are making an assumption that, okay, these variables are constant, and then you are trying to see the impact of one variable on the other. So that is where you are making an assumption. Similarly, in your model, when you're talking about, when you're building your model and you're basically doing different tests, so you are assuming normality of the variables, or the distribution, or like the properties of standard error and so forth. So all these different assumptions you are making when you're building the model. So that actually kind of sort of creates a boundary, as in how within which ambit your model is correct. Okay, so that is another way we say that we sort of look at the econometric model to sort of ensure that we try to ensure econometric model is correct by making assumptions. The third part is the diagnostics test. Okay, so all the different techniques that you have learned, the different problems that you can see in a model that which we have explained previously. So all those problems we try to identify in this diagnostics test. For example, the functional specificity, or multicollinearity, or heteroscedasticity. So all these different actually problems that we see in a model, we want to ensure that the problems are not there. So we essentially do the different tests to actually get to the remedy of the problems. Okay, and then of course once we identify the problems, we sort of try to remedy those problems. And when we try to remedy those problems, we actually sort of also get a sense of which variable might be creating the problem. If you excluded some variable, for example, in omitted variable bias, if you have heteroscedasticity or autocorrelativity, so you might actually think that perhaps you have omitted some variable, and you try to see if you have actually omitted some variable, and you try to include that. Okay, so we're just going to talk about the omitted variable bias problem in a while. All right. Now there are two ways. Now if the model specification problem, as I said, model specification problem, we have the first problem we said, let's say exclusion of relevant variable. Okay, so this is the first thing we are going to discuss, and then we'll talk about inclusion of irrelevant variable. Irrelevant variables. Sometimes you don't remember the correct spelling. So exclusion of relevant variable, let's say. So this is something we call as omitted variable bias problem. Omitted variable bias problem, or OVP. Okay. So when we actually omit a particular variable, so let me elaborate this omitted variable bias problem. So when you actually sort of exclude a particular variable of interest, now there are two ways that variable of interest can actually influence your model. So one, it can, let's say I have a model, let's say I have y, and then let us say I have included a variable x2, and there is a variable which you have omitted, which is actually present in your model, which is x3. Now, if you haven't included x3 in your model, so what will happen is that there are two ways your x3 can actually influence the y. Okay, so it will, I will use a different color. It will influence either through the error term. So, it will basically take the error root. So, where x3 and x2 are not related. So, then it will influence the y through error term and influence the y through error term, or it may also include y through x2. Okay. So, instead of error term, it can actually influence through. All right. So, there are two ways the omitted variable can actually influence your model, and we will explain how the two paths can actually show us different results. So, let me explain the first part in this lecture, and we have already explained that in fact previously. So, that first part is actually, you remember the problem of heteroscedasticity or autocorrelation. So, first part is essentially that we have already talked about it. When I have omitted a variable and that variable is actually influencing my y through x through my error term. So, that is where my problem of heteroscedasticity or error term is autocorrelation is coming. Okay. Now, in this case what is happening? We see some pattern in the error term because some variable is actually excluded from my model. So, what is happening? The entire pattern due to that x3 variable is being captured by u, and when it is captured by u, what do you see? There are some either u is correlated with y in cross sectional data when you see heteroscedasticity, or you can see a correlation between u error in different time period, right. So, that we see in autocorrelation. In both the cases what is happening is that because u is getting inflated, because the error is getting inflated, the variance of the model is getting inflated, and when you basically estimate the t statistic, so the t statistic is going to be, so you are dividing the coefficient with a higher variance, and the t statistic you get is lower, and as a consequence what is happening is that you are finding certain variable to be significant, whereas they might not be significant, right. So, that is a problem that you see in the case of heteroscedasticity or autocorrelation. So, this omitted variable, so this is the first thing. Let us say the assumption is that omitted variable is actually influencing the y through u term, the error term, and when that is happening, I am getting either heteroscedasticity or autocorrelation. Okay. All right. So, that is through the case 1. Now, we will talk about the case 2 when x3 is actually influencing y, sorry, x3 is influencing y through x2. Okay. And that we will, and there we will see the extent of bias and extent of inefficiency that is being created. In this case, we have already seen in heteroscedasticity or autocorrelation, there is no bias problem, but the problem remains in the fact that the standard deviation is is a problem. The model is inefficient because it is not the best model. We have this in the model that we get here is having a higher variance. So, we do not want that. So, with this we will end the lecture, and in the next lecture we are going to talk about the second part of the omitted variable problem, omitted variable bias problem, where x3 is actually influencing y through x2 root. So, with this we end this lecture here. Thank you.